For Unit 2, Learning Set 5, you're going to learn about the compound interest formula. The first video is going to help you become familiar with the derivation of the compound interest formula, and the second video will make computation using the compound interest formula. So in this first example, Jose opens a savings account with a principal of P dollars that pays 5% interest compounded quarterly. What will his ending balance be after 1 year? So we're going to, and remember, when we're talking quarters, that means it is done four times a year. Okay? So 4 times a year means every 3 months is how often you compound interest. All right, so to figure out our variables for the first quarter, principal is going to be our P that we highlighted in yellow. Our rate is going to be the 0.05. And remember, if we're doing it every 3 months and time is represented by years, that would be 3 out of 12 months, or it would be reduced to 1/4. Notice in the fraction, the 4 represents how many times a year it's compounded. So we would calculate our interest, which would be P times 0.05 times 1/4. Simplify and combine what we can, which ends up with 0.05 divided by 4 times P. And in this first section, we're going to let B represent the balance for the first quarter, the ending balance. And remember, to determine the ending balance, we have to add our principal plus our interest. So for B sub 1, our balance is going to be P plus 0.05 divided by 4 times P. Now, if you think about this, notice on both sides of the plus sign we have a P, which means we can use our distributive property to pull the P out and make it P times the sum 1 plus 0.05 divided by 4. So now remember, our ending balance on here, that now moves up and becomes our new principal for the second quarter, because once we've earned interest, it's our money now, it's in our account. And the rate and the time do not change. So once again, we calculate our interest, except for this time, it's going to be 0.05 divided by 4 times B1, B sub 1. So we had already combined what we had done in the first one and put in our new principal amount for B1. And then for this ending balance, we are going to use B sub 2 to represent the ending balance. So B sub 2 is B, the balance for the second quarter. So we put in our B sub 1 principal plus our 0.05 divided by 4 times B1. And it's going to equal, because once again, like we pulled the P out before, this time we can pull out our B1. And we have B1 times 1 plus 0.05 times 4. And we used our distribution property again, distributive property. So now what we want to do is we want to substitute P times 1 plus 0.05 divided by 4 for B1. And when we do that, you're going to notice that we have 3 terms that we're multiplying. P times 1.05 over 4 times 1 plus 0.05 over 4. So we have 2 of them now. So we have 2 of the same thing. So we can take and write that as squaring it. Okay, so now we have the balance for the second quarter, B sub 2 equals P times the sum of 1 plus 0.05 divided by 4 squared. All right, so for the third quarter, remember, for the third quarter, we are going to be using the ending balance from the second quarter. That's going to become our new principal amount. So everything else is the same. We find our rate, except for this time it's B sub 2, because we're using the balance from the second quarter. We plug in everything just like we did. B sub 3 equals B sub 2 plus 0.05 divided by 4. And you find we can do the distribution property again. And this time we're going to substitute P times the sum 1 plus 0.05 divided by 4 squared for B2. And don't worry about this if this is a little confusing looking at this. Remember, the notes will be available on Schoology, so you can always look at this individually. This is just showing you how we get to the compound interest formula. And we end up, notice on here, we're in the third quarter and our exponent value is now 3. Okay? When we were in the second quarter, our exponent value was 2. So think about it. What do you think our ending balance equation is going to look like for the fourth quarter? So we use our ending balance as our new balance up here. And then we're going through the interest, except for this time it's with B sub 3. Same thing. And if you guessed that our formula at the end of the fourth quarter, the number of quarters we had matches the number in the exponent, you would have been absolutely correct. So let's look at this next example. Rico deposits $800. That's our principal at 3.87%. That's our rate. Compound it quarterly. So that would be 4 times a year. Okay, what is his ending balance after 1 year to the nearest cent? So we figured out a general formula in our last one. Our last example. So B sub 4 equals principal times 1 plus 0.05 divided by 4 to the fourth power. That was the formula we ended up with when we compounded quarterly in our previous example. So all we have to do is we have to put in, well, we know that 0.05 is the rate. Okay, so that means we can substitute R for 0.05 to represent the rate. And then all we have to do is put in our principal and our rate. So we would put in 800 for the P value, and then our rate would be replaced with 0.0387. The 4's would stay the same. Calculate it out, and we get $831.41. So let's continue to use the formula that we had from example 1. Okay, so I'm going to rewrite the formula from example 1. If you deposit P dollars for 1 year at 5%, compounded daily, so this is what we're looking at, compounded daily, express the ending balance algebraically. So notice the exponent and the denominator are both 4, which represents the quarterly compounding amount. So if we were to compound daily, we know daily is 365 days. All we would need to do is replace replace 4 with 365. All right, so next example. Nancy deposits $1,200 into an account that pays, so that's our principal, that pays our rate of 3% interest compound it monthly. Monthly is 12 times a year. So you see what I'm getting at here when I'm talking compounded? I'm looking at how many times a year it happens. So if it's quarterly, it's 4 times a year. If it's monthly, if it's 12 times a year. If it's daily, it's 365 a year. And this is going to become important in the next video. So what is our ending balance after 1 year? Round to the nearest cent. So we're going to replace the 4 from example 1 formula with a 12. So remember, when we did the daily in the previous example, we replaced the 4 in the denominator and the 4 in the exponent with 365. Well, now we're talking monthly. So that means the 4 is going to be replaced with 12. Now we can remember that this top part represents our rate. Okay, so we would replace our principal with 1200, our rate with 0.03, and then we calculated it out, and our ending balance to the nearest cent is $1,236.50.